You know, when you picture a major scientific breakthrough, this probably isn't what comes to mind. This whole story starts not in some sterile lab, but in a place you would never, ever expect. It all kicks off with this very specific moment, recorded almost like a diary entry. It's so personal, so immediate. So forget the white lab coats and humming server racks for just a minute. And get this, the setting is a picnic table looking out over an ancient Welsh castle, a place just steeped in history. It's this amazing contrast for the super modern story that's about to unfold. So you have to ask, right? Is this really where world-changing science happens? Overlooking an 800-year-old fortress on a Sunday afternoon? Well, the answer is a big, resounding yes. Because this is the story of a really significant breast cancer discovery done completely from start to finish on a Samsung Galaxy phone. And no, this isn't science fiction. This is literally what happened at that picnic table. Okay, so let's get into it. The setting is amazing, but what did they actually find? The data pointed to this powerful new genetic signature. Think of it like a unique pattern in a patient's genes that was strongly connected to their chances of survival. And at the heart of this pattern are 25 specific genes. By looking at how active these genes are inside a tumor, a clear pattern popped out that could sort patients into different risk groups. And here's where it really hits home: the human impact. The signature sorted patients into two buckets. For the high-risk group, there was a 44% chance of the cancer returning or worse. But for the low-risk group, that number was just 8%. That is a huge, huge difference. To put a single number on it, patients in that high-risk group were over 5.5 times more likely to have a negative outcome. I mean, that's a signal so strong you just can't ignore it. And this visual, wow. It shows you exactly what that data looks like. This is a Kaplan-Meier curve. See that red line? That's the high-risk group. The blue line is low risk. That massive gap between them, that's the proof. It shows just how powerful and statistically significant this 25 gene signature really is. So how on earth was this level of analysis even possible on a phone? Well, it all comes down to a pretty revolutionary AI tool. Let's dive into how it actually works. It's called Odin, and its secret sauce is that it's a deterministic AI. And trust me, that one word changes everything about how we can use AI in science. So what does deterministic mean? It's actually pretty simple. You put the same data in, you get the exact same result out every single time. There's no randomness, no mystery. For science, where being able to reproduce your results is the absolute gold standard, this is a total game changer. Think of it like this. Most AI we hear about is black box AI. It spits out an answer and just tells you, trust me. But Odin is a clear box AI. It's like a glass box. It doesn't just give you the answer, it shows you every single step, every calculation it made to get there. And that's the whole philosophy here, right? The system isn't asking you to just trust it. It's handing you the full audit trail and basically saying, go ahead, scrutinize me, try to prove me wrong. Now that is real scientific confidence. Okay, but a discovery this big, made in such an unusual way, you have to ask, is it for real? Did the signal actually hold up under some serious pressure? Oh, it was put through the ringer, all right. A brutal validation gauntlet. First, the initial discovery. Then it got hit with intense stress tests. After that, it was tested on a totally new group of patients. And finally, it faced a holdout group the system had never, ever seen before. And how did it do? Unbelievably well. I mean, the signal was so strong, it stayed stable even when a third of its core genes were just yanked out. It held up when they threw random noise into the data to mimic messy real-world conditions. Then it was validated on a completely separate group of almost 3,000 patients. And finally, confirmed on 546 more. This thing is tough. But here's maybe the most important part. This wasn't just finding something we already knew in a new way. The current clinical gold standard is a signature called PAM50. This new 25-gene signature has 0 genes in common with it. That means it's very likely looking at the cancer from a completely different biological angle, a brand new piece of the puzzle. So let's zoom out for a second. We've got a new, super robust signal found on a mobile phone using a totally transparent AI. What does this all mean for the future of research? Why does this story matter so much? It matters because this completely changes our idea of where and how science can be done. This didn't happen in a massive university lab with millions in funding and a server farm. It happened on a phone. This democratizes discovery. It means powerful research can happen faster, cheaper, and in places that don't have massive computing resources. So let's go back to that picnic table one last time. The researcher noted that the castle behind him has stood for 800 years. This monument to enduring ancient structures. And on that exact same day, Amethyst CoS, the operating system that made all this possible, launched. You have this incredible collision of the ancient and the brand new happening at the exact same moment. It really feels like a turning point. And it leaves us with this one last, really fascinating question. If the last 800 years gave us that castle, and today gives us biomarker discovery on a phone, what will the next 800 years of discovery look like when anyone, anywhere, has this kind of power in their hands?